Welcome. In this example, we will take a look at whether we might be able to predict life expectancies in a country from birth rates. So provided is the bivariate data giving birth rate and life expectancy information for each of 12 countries. For each country, both X, the number of births per 1,000 in our population, and Y, female life expectancy in years are given. And then they've given us the scatter plot as well as the least squares regression line. All right, so the first step would be to enter that data into our calculator L1, L2. So I've done that already. If you wanted to pause the video and enter that data, and then we pick up from there. All right, so part one here is correlation. So we're going to conduct a hypothesis test for the significance of the correlation coefficient. So our null hypothesis will be rho, the population linear correlation coefficient is 0. That would indicate there is no linear relationship between the variables. And the alternative hypothesis is rho is not equal to 0. All right, and so to test for the linear relationship evidence between the two variables, we run our linear regression t-test. Let's go to our calculator here, stat tests. I usually scroll up to get there more quickly. Linear regression t-test, L1, L2. Then you want to make sure it's a not equal to for the alternative hypothesis. And you can learn by watching another video how to graph the actual regression line. And that's why I have something here for regression equation, but I'm going to clear that. That's not necessary. So if yours is empty, that's totally fine. And then calculate. And then let's scroll to the bottom of that screen and write down our sample correlation coefficient, and that's negative 0.916, rounding to 3 decimal places. And negative correlation makes sense here just based on the visual of the scatter plot. And to determine if that's a significant value for the correlation coefficient, we'll go to our p-value. And I'm going to see here our p-value is incredibly small. So the calculator switches to scientific notation. So just so I can put something in the notes here, I'm going to take that first digit and round it. Has an 8 next to it. So 2 would go up to 3. And then I'll take care of the e, -5, which means move the decimal left 5 places. So that will be 0.0000, and then 3. All right, so once your calculator switches to scientific notation, that's pretty much a guarantee that your p-value is less than or equal to alpha. And in particular, the next line says at a 0.05 alpha significance level, so that p-value is definitely low, so we reject the null. And so we say that that correlation coefficient from the sample is statistically significant. So we've got ourselves good evidence, strong evidence that there is enough evidence to conclude a linear relationship between birth rate and female life expectancy. All right, so that's correlation. And then regression analysis is finding that equation that describes that relationship in the population. So let's do that next. All right, so let's write the equation of the regression line. We're going to round A and B to 2 decimal places. So for the regression line, we're going to do y hat to represent the y value on that line. And then on the calculator here, A is 81.42. All right, so it's A plus BX, but B is negative. So rather than writing plus a negative, I'm just going to write minus. And then B is 0.45, negative 0.45 times our variable X. All right, next, let's talk about pairing. So in this example, again, we have a negative slope. So I'm just going to make a note here that negative slope, I just informally call this opposite pairing, meaning when one variable goes up, the other goes down, and vice versa. So for female life expectancies that are less than the mean, I would see tending pairing of birth rates that are the opposite, so not less, but greater. All right, so female life expectancies that are lower than average tend to be paired with countries with higher than average birth rates. All right, part C. According to the regression equation, for an increase of 1 birth per 1,000 people in birth rate, there's a corresponding decrease of how many years in female life expectancy. So when we see that phrase for an increase of 1, we know they're referring to the slope of that regression line. So the slope is the value of B. So the coefficient of X, so that's negative 0.45. And then by writing that as a fraction, putting it over 1, we can see why they're phrasing it this way. So it's change in Y over change in X. So the numerator is the change in lifespan or life expectancy. Just abbreviate here. That's the change in Y, change in life expectancy, and the denominator is the change in X, and our X represents birth rate. So as the birth rate goes up by 1 per 1,000 people, there's a corresponding decrease because it's a negative slope, and the decrease would be 0.45 years. So the slope is negative, but write a positive number there because we said the word decrease, so how much it goes down. All right, and then we can also use the regression line to make some predictions. So what is the predicted female life expectancy in years when a country has a birth rate of 42.5 births per 1,000 people? So they're asking us to use X, 42.5, substituting into our regression equation, which is what we use to make predictions. So Y hat was 81.42 minus 0.45, and for X, we'll substitute 42.5. And I will enter it on the calculator exactly like I wrote it. So 81.42 minus 0.45 times 42.5. And I did not indicate what to round to here, so I'm just going to write that entire value, 62.295 years. All right, so this represents on average any country with that birth rate that on average we expect that to be the female life expectancy. But we did actually observe a country in our data that did have a birth rate of 45.4 births per 1,000 people. So that value is Y, what we observed in the data. And so I have to scroll up here. So there's my 42.5. And let's go ahead and label that on the graph as well. So that value on the scatter plot, so that point is our XY value. So 42.5, that country had a female life expectancy of 66.1 years. And what we predict on average, so that same X value, but on the regression line, so 42.5, our Y hat came out to be lower than 66.1. It was 62.295. So this particular country in our study actually has a female life expectancy higher than average for countries with a birth rate of 42.5 years. All right, there you go. That is a complete problem on correlation, testing for significance of correlation, and then moving on to regression. And I'm just going to write that final answer down here from the table again. So that was 66.1. That's what we observed in our data.